So we will start with the session today. Up to this point, we have covered the first day general introduction to data systems. So if I do the recap, so let me just quickly do the recap for so okay. So we'll do the recap first before we get into the logical architecture. Day one, we saw the two systems, the OLTP and OLAP. Then the second thing that we saw is what is the procedure for converting a current system into logical system. That means I have to come from the basic to what we call as implementation. So whenever a system is created, whether it is OLTP or OLAP system, OLTP system is mainly meant for transactions. Like you go to a store, Reliance store, and then you buy something, transaction is happening, the data gets stored in OLTP system. Then we have OLAP system. So the OLAP system, the data is used mainly for the purpose of accessing the data for the analysis. Okay, Srinivas, am I audible now? Manasi, am I audible?
Yes, sir.
Okay, thank you, Manasi. So yes, Srinivas, am I audible now? Okay, I think. Okay. So the two systems, OLTP and OLAP. OLAP is mainly meant for analysis. Srinivas, am I audible now for you? Just give me a minute. We'll continue. Srinivas is not able to. Yeah. Okay. Yes, I think I'm audible to everybody now. So let us proceed. The two systems, OLTP system we have seen, OLAP system. Then we saw that OLAP system is basically meant for the analytical part. And therefore, we saw there is a difference between the two database systems. We are going to be looking at OLTP system. In OLTP system, we saw the process which takes you from requirement gathering requirement for the database. From requirement gathering, we saw the process going up to implementation. And we saw various stages in this process of converting. The stage 1 being high level design, which is called HLD. Stage 2 we call as the modeling. Stage 3 we call as low level design, where we optimize the database. Then stage 4 we implement. Now this is to give you the basic introduction. This portion is not covered in this training, so this portion we are not going to look at. Assuming that the tables are given to you, you are going to see how to implement these tables in your system. So we are looking at implementation. In here, we have seen that the modeling that we use is ER modeling. So at high level design, we just decide where the data will reside, the distribution of the data. And low level design, we will decide how to design the tables which are modeled and how many tables will be there, how they would be linked, etc. And finally, implementation is you will have the table created. So for creating table, we require a database engine. We have chosen SQL Server as the database engine. So this is the story so far. And we come to SQL Server. And in SQL Server, we have seen what is the logical architecture. So logical architecture of SQL Server. Logical architecture means what are the components that are present in SQL Server and what that which is relevant to us we are going to be looking at. So I just did a recap of what we have done in the first 2 demo quickly. So those who have not attended the demos, so I see Srinivas is new, and I think I also see Yagnesh. So Manasi also I think did not attend the second day on Saturday. So you go and take a look at the demo. Demo has been uploaded in YouTube. So today we will continue with the logical architecture part. So we will do a recap quickly on the logical architecture. So for understanding logical architecture, we need to understand what is the basic component or the object in SQL Server. So the basic object in SQL Server is the SQL Server engine instance. So this is the engine instance we have seen. Now there are 2 types of instances. One is called the named instance. The second one is called the default instance. Okay. So the default instance will have the name of the server. So in my case, I have the system. The system's name is Brahmamayam, and the name of the system is also the name of the instance. So it is like any other application. The SQL Server is like any other application like Word, text, etc. Now, the advantage of SQL Server is that it can have multiple instances. That means you can have multiple EXEs running simultaneously in the same server. It's like Word. When you open Word, it is a multi-document interface. So you'll have only one Word.exe. But when you open Notepad, you can now Notepad has become multi-document interface. But initially Notepad also, when you open multiple notepads, multiple EXEs will open. Similarly, SQL Server, every instance, every engine, every instance of the engine you open, it will open an EXE. And how do you see that? You have to go and see using the task manager. So when you go to task manager, I think the task manager will be visible. So here you will notice that in the task manager, you will have SQL Server.exe. So just put in SQL. So you can see here Microsoft SQL Server. So you have all of this analysis service. SQL Server browser is there. Yeah, SQL Server Windows NT 64-bit. So this is the process that is running. Because one engine is running here, one process is running. Now, this is called single instance. Now, if I am going to install once more, you can install many instances. So one instance is the default instance. It is called default because it is by default installed when you install the first time. From the second instances onwards, you give the name and that name will appear here. So you can see here MS SQL Server. This is a service. Now, from the next time you install, you will have multiple more below SQL Server, Windows NT 64-bit, and it will tell you what is the CPU usage, memory usage, etc. So this is how you come to know. Similarly, Notepad, if you see here, so if I look at Notepad, I have opened Notepad. So when I look at Notepad also, you can see notepad.exe. So you can see one Notepad is now active. You can see here, right? So this is a single instance engine or application. SQL Server is a multi-instance application. So this is the first instance. I have only one instance installed in my system. Going back to the logical architecture, you see that the system has one database instance. So this is my database engine instance. Okay, so we will have that. This is the database engine instance. We'll just remove this part. This part is a little confusing. So the system has one database instance in my case. Now each database instance will have many server objects. So server objects are objects which are under that instance. So here server means SQL Server. So let us look at this. So you have this SQL Server instance, and under the SQL Server instance, you have many objects, physical, logical objects. So you have database, you have security, you have some specific server objects. Here, server means SQL Server, replication, polybase, etc. So you have many such objects under SQL Server instance. And that is what is represented here. So you can see there is one instance of SQL Server, and that instance has many server objects. Anybody wants to talk? I am able to. Satya. Hello, Satya. Satya, mic is. Satya, your microphone is not at mute. Okay, so I just muted. So this is your instance. So the database, you have server objects. Now under server objects, we have seen that the database is one of these server objects. So you can see the databases here, the one of these server objects. Now under the databases, you have two types of databases. One is called the system database, and the other one is called the user databases. So you have system databases and user databases. Now, the point that we will try and make in here is to see what is the difference between the two. We have seen it, but I would like to summarize using a presentation. So we will see what are the system databases once again. So the system databases here, the first database that you see is the master database. So you can see that very clearly here. You have the master database. Now, the master database is used to store the login account details, the system configuration. System means SQL Server configuration, like who are the users who can access, whether the server will run in on one processor or multi-processor, all this. Then other databases in the server. So you have so many other databases which are called user databases. That information will be present in your master DB. So master DB, as the name suggests, is the master containing metadata, information about other databases. So this is the master DB information. Then initialization information will be there. Initialization information means which database, what connectivity, how should it connect using which particular authentication mechanism, etc. And which databases should come online, which databases should not be available. All this information is present in here. So this is the initialization information that we are looking at. And then the most important thing is the master DB being the starting place where the data is and the server starts. When the server starts, it will look at master database. So it is important that you have the backup of this master database so that in case of eventuality, the master database can be restored and you will be able to access the SQL Server. Otherwise, this access that you are seeing, that is also not possible. Before we proceed with the other database, a quick comeback, something that I have missed to tell is this is the tool which is called SQL Server Management Studio. I did introduce that in the previous class, but most of you are new in this class. This is called a SQL Server Management Studio. If I go to Start Program, that particular Management Studio will be available. So go to Start here, and as you can see, SQL Server Management Studio. I hope all of you can see that SQL Server Management Studio. You can see. So that Management Studio will be available. So SQL Server Management Studio is open. That is a client tool using which I am connecting to the SQL Server Database Engine service. So let's go back to master database now. So we have the master database. So we have already seen what is the purpose of master database. The second database that you see in SQL Server is your TempDB database. What is the purpose of TempDB database? So it's a recap, a summary. So you have temporary tables which store information temporarily. And those tables get stored in the TempDB database. Similarly, you have something called stored procedures, which we have seen. Stored procedure is nothing but a set of instructions. Like if I want to withdraw cash, what all I need to do in the database so that the withdrawal of cash is complete and all the information is entered in the database. So a stored procedure. So you can have all temporary. So for any temporary storage need, you use the TempDB database. You in the sense SQL Server. You can't specify, but you can create these temporary tables. Suppose you feel that there are certain tables I want to store the data for some time. You can create the temporary tables. So global resources which are shared across multiple users, that also get stored in the TempDB. And every time you restart the SQL Server, it will recreate, because this is like a scratchpad area. It's like in your exam, you want to write something in the rough, you want to calculate. There is some area, and that area is called scratchpad, and that area is what we are looking at. Then you can also have RAM. On RAM, the older versions allowed this table to be present in RAM. Now it is not so, but the older versions. Then the next database that you see here is the model database. So you can see here the model DB. The model database, its main purpose is it acts as a template to create other databases. See, when we will be creating a new database, like going right click and you say new database, you will create user databases. So you can see here I have created one test. Now this database by default will have certain tables, which are system tables, certain views, and certain folders. You see the structure, all the information, the data and the structure of this database. How does SQL Server know what is going to be the structure? What are the objects in the table? And there may be certain tables which have to be created as part of system table. And how does it know that I have to create this table, dbo.userinfo? Because that information is available inside the model DB. So if I create a new table in model DB, like let's say you create a new table and I'm just naming it as test. And I save this and say this is for testing template. It's just a database table I have created. So this table gets created. We don't need to worry about how to create the table now, because that we will be covering later. This is just to show you. So I have created this table. This table is already there. So any table you want, to be created whenever a new database is created. That table, it will be present in model DB. You can create. So now when I create a new table, a new database called testing2. So don't worry about these files, etc. We are going to come to it. So I say testing2. So when I do that, what happens is it will create this new database. And in this new database, it will create the tables which are present in as part of the template. You can see these two tables because these two tables are present here as part of the template. So your SQL Server, in SQL Server, we are seeing that the model DB is used for creating tables which have to be used across various databases. And these tables are tables which are created by user, and there are certain system tables also. It will not be visible in this view. We will see later how to access these tables. And therefore, this is how we use the model DB. So what is the purpose of the model DB? It is acting as a template for all the databases. So you can see it is a template. It is used during create database call. So when I say create database, you create the database and it uses this model DB. Then all the contents of the model DB is copied into a new DB. So when you create a new DB. One important thing to note, whatever you create using model DB will not affect the existing database that is created. Okay, so this is, you see the testing2 has these two databases, but we had already created the test database. You see there's only one table. So any new database you are creating, it will have the tables from the the model DB database. Right. So now we move on to the next part. What is the next database? That is the system database, the MSDB database. So that is the only database that is left. The MSDB database, the purpose is more of admin related purpose. Admin related purpose means alerts, jobs, operator information. So your database will have certain jobs to be done. Now, those jobs mean like backup, restore, so that planning is done. And therefore, sorry, I'm just pausing. Divya, audio is there. Everybody is able to hear. So can you just check from your end? So, yes. Okay. So, yes, so let's continue. So you have alerts and you also have jobs. So alerts, like for example, if the database space is full, then an alert has to be sent to the creator of the database. You may want to do backup, so alerts. So there are certain jobs also that are there. So creating alert, creating job, and then information about for whom the alert is created, for whom the job is created. So admin related in general. How do I maintain the database? So for maintaining the database, certain things have to be done, and that is available as part of operator information. So this is what we look at. So these are the 4 system databases that you see. So we can see the system databases that is there here. Now, the next part of the logical architecture, let us go to the next component of the logical architecture, So we have seen the server here. Just so once this server object, the database we have seen, the system databases, you can create your own databases called the user database. So we have the user databases that can be created. Now, each user database can have multiple database objects. So let's go to the database object and see what are the database objects that you can have. So you can see here, just give me a minute. I think something is wrong. Uh, yeah, now it's fine. So I was not getting the mouse pointer. So now, so these are the user databases. So we have created some like the test database and the testing two databases. So you have the master data, the system databases and the user database. Now, after we have seen the databases, within the database, especially the user database, now we will go into, because system database we are not going to touch. It is mostly done or it is mostly maintained by administrators. So we have database objects. So we have user table, you have system table, etc. So we have different database objects. There can be many database objects in here. Now, what are the database objects that we can have? Let's look at the user database and see what are the database objects. So you have some diagrams, we have some tables. What are these? We will come to know as we proceed. So views, there are some external sources, there is synonym, then there is programmability, server, service broker, storage, security. All these are all objects or components under the database. So database components or components under the database, they are called as database objects. Now looking at this component, okay. Okay. Again, there's a issue of audio. I'll just check once. Uh, don't worry, these seem to be a teething problem. Divya, can you okay, so I've sent a message. Let us continue now. Again, so okay, so I think Divya is not able to hear. Yes. So somebody has dropped out. Yeah. So we will again continue. Sorry for the interruption. So therefore, what we were looking at is what are the database objects. Now the database objects that are there, the most important object for us is the table, because we are looking at table design. We are assuming that we are going to create the table, and we will start from the beginning. So assuming that our main focus is starting from creation of table becomes one of the database objects. So when you look at the logical architecture, you can automatically see that there is a table. And again, the table can be divided into two. You have system table and user table. So let's look at the tables here. We have seen already that there are two subfolders, system tables, and the other one is user table. It is present directly in the under the tables folder. So under the tables folder, a system table folder is there. Any table which is used by SQL Server for storing information about SQL Server tables is present in system tables. And all other tables which store information about the user is present under user table. So these are your user tables. These are your system tables. So like you can open up any database and you will see that there will be two sets of tables. The system table is there, and then you have the user table. So this is how we have the architecture now. Now, question is, where does the information about the tables get stored? So tables information gets stored in file, which are present under file groups. So let us first look at the portion here. So if I go back now to the organization of the logical components, so we are seeing under the database, you have table, indexes, views, stored procedures, defaults, constraints, triggers. There are many such objects, and some of these objects are present in folder. Now let's go in here. What is the way the DB or the database is organized? So a database is having initially logical container, which is called file group. So you have three logical containers. If you see here, primary, my file group 1, or my fg1, my fg2, you can create many more. So anytime you create a database, it creates a logical container. It's like a folder, if you can say. So it will have this logical container, which is called a file group. There is a default container which gets created when you create any database, which is user database, and that is called the primary file group. Now let's look at the primary file group here. So when you go and create a database, so we created a database called test here, test example. So in this database, if you see, how do I find out? So you go to the properties of the database through SQL Server Management Studio, and you will be able to find out how many file groups are there. So you can see whenever you create a database, by default, it creates one primary file group. File group is a logical container of all the data. So you are going to create some tables here. The table will go and sit into this file group. File group is like folder. Can I add new file groups? You can see you can add more file groups. So let us see, when I create also, it gives me this option. And I say I want to create a new database. You can clearly see that by default, it is there only one file group is there, which is called primary file group. And that is what is given here. If you see, this is the database that you are already created or you're going to create, and then you have the primary file group. And why is it called default? You can see it is a default option. I don't do anything. I did not add any file group. It is a default option. So you have that file group that will get that will get created automatically as a default option. So once this file group gets created, inside the file group, you will also see you will have files. And that is what is shown in this diagram. So within the file group, you will have files. And ultimately, data in the database is stored in the file only. And these files are called data files. And the first data file that gets created, which is again default, you don't have to do anything. When you create a database, the first database that gets created is called the primary file. If you see in this diagram, f1.mdf is the primary file. And this primary file is present in the primary file group. So you have the primary file group, the primary file, and the database. Now, can we create more files? Because by default, it allows me to create only the primary file. So can we have more files? So we can see here, when I create a database, like if you go to test example, this database, so you can see, because the file group is 1, and in that file group, you have only one file, and that file is called a primary file. So you can see the primary file here under the primary file group. Don't worry about the log file now. We will look at it later. So there is a primary file. Now, once the primary file is done, then you can see here in the file group, it will tell you what is the size of the file, etc. This is called as the primary data file. What is the extension of the data file? It will be stored under the name .mdf. So MDF is actually the primary data file. Let us go and look at, can I see the primary data file? So if I go to the C drive, program files, you will have Microsoft SQL Server. Under Microsoft SQL Server, the folder, the version folder, which is MS SQL 15. And under that, you have MS SQL and then data. So you can see the file here. So we talked about a file for test. So let us look at the file. Here you can see. So test example is there. So you can see here test example, SQL Server database file. So this SQL Server database file, you can see is created. This is called as the primary file. And if you look at the properties of this file, it will be .mdf. The extension will be .mdf. You can see that here. So can you see the MDF portion here? I cannot magnify it, but you should be able to see the MDF portion here. So this is your MDF file. So all your data, that means you create a table, you create columns, then you create rows for the table. All this information goes and sits in the data file. And this is the primary data file. Now the question can be, can I create more? So as the diagram shows here, you can create other data files in the same file group. They will be called as secondary data files, and they will have an extension called .ndf. So let us see how that can be done. So I have this test example. So under test example, if I go to the properties, it shows right now that there is only one file called test_example, which is a data file. I can go to the file groups, and to this file group, I can either add a file group or I can add a file going to this file menu here. So let me add a file. So it will automatically add one more row here. And in here, I can say test_example_new. So this is the name of the new file. And this file, if you look at what type of file it is not a log. So far you can see only two types of files. Rows data. Rows data means whatever data you are going to store inside the table, that data goes and sits in the file. This is log file. We will cover log file later. Right now, we are not worried about that. And then here also you see rows data. So the data file. So there are two data files. This test example is the primary file. And this is the secondary file. This is called as a secondary file. And the file group, which is like a folder, logical container, this file group contains the two different files. So when I now say OK, there are two files created under the file group. So let's go back in here and you can see that there are two files created under the file group. So to summarize, you have a database and the database has a logical container which is called as a file group. The default logical container is called as the primary file group, and every primary file group, that means primary file group in every database will have a primary file, which is the .mdf, and you can create other new user-defined files. That means you can create your own files apart from the primary file called the secondary file, and the extension will be .ndf. We can check the extension once. So if I refresh this part, say data, I refresh, so test exam new. Should be created. So yeah, so it's created here. And if you look at the properties, you will see it is the extension is .ndf. Okay, this is how the files are created. Now question, can I create more? Yes, there is a limit that SQL Server imposes, but within the limit, you can create as many files as you want inside the file group. Now, why the extension names are different? Because this indicates that this file will contain mainly metadata, not data, metadata. Like for example, table is there, name of the table, how many columns the tables have, name of the columns, how many indexes the table have. We will be covering just in brief what index means. So all that information will be present in the primary file. Suppose I don't create a new file, then my data in the table also will go and sit in the primary file only. So you have two types of data. Data which is called metadata, data about data, then data which is called user data. So you have user data and metadata, both are there. So we are now looking at where the metadata sits. Metadata will only sit in the primary file. But if you don't create a secondary file, user data will also go and sit in the primary file. But if I create a secondary file, then the user data will go and sit in the secondary file. That is why it is called .ndf. It is to differentiate. M stands here for metadata, the main metadata file. Okay, and what is the recommendation? SQL recommends that you create secondary files so that data, user data can be stored there. Because if the user data gets corrupted, and if you are storing it in the primary file, the other data is also corrupted. Then what happens? You will lose the entire database. And therefore, the recommendation is you have the primary file where you store all the metadata, and then you have the secondary file where you store all the data. Now, just like you have primary file group, can I create more file groups? Answer is yes. They are called secondary file groups. So let's go and see how to create the secondary file group. So when you go to this database, say test example here, you go to the properties option. You can create file groups here. So so primary file group, it says it has two files. I can add a file group and I can call this secondary. Now, when you are creating a file group, you need not create a file for that file group. It will just be there. It's a logical container. So when I say yes, it has created a secondary file group. In fact, the recommendation is you always create a secondary file group. And you avoid creating multiple files in the primary file group. Like what we have created is not a good practice. So you always have one file. So what we can do is we can actually go ahead and remove this because it's not a good practice. I showed you this example just to show that you can create multiple files in the file group. So I'll now delete this. So you have the file called test example under primary. That is the primary file. And now when I add a new file, I will not add it under the primary file group. I will add it under the secondary file group. And I'll call it as test example secondary. So once this is done, it has created the file. Okay. Okay, so I'm not able to remove the older one. So I have to recreate the new one because there is some data inside it. So cannot remove. So you can see I'm not able to remove this because some data is already created. But this was just to show you we can create a new file inside any file group, and the same stands for primary also. The primary file group is there, a new file is created. But good practice is create a secondary file group and all your data files will be in your secondary file. So what happens very clearly, if you go to the diagram, the primary file group will be used to store only system data, and the secondary file groups will be used to store user data. Now, when you create files inside the file groups, whether it is primary or secondary, you can specify the drive. In this case, you can specify whether it is D drive, C drive, you can specify the drive. Advantage, what is the advantage of that? Advantage is data gets distributed across different drives. What if my C drive is full? Then the data will go and sit into the D drive file. So there will be no problem. So we have to ensure within a file group, you create files which are present in multiple drives. So you can see that example in here in the file group FG1. Similarly, you can create multiple other secondary files or file groups. So this is how we go on to organize a database. Okay. Now let us see what we just talked about. So we have the primary data file, the .mdf, which will contain schema tables. Schema table means tables which contain information about other tables which are going to be created. It will be one per database. That is the primary data file. Then you have secondary data file. It is optional, but it is a good practice that you create the secondary data file, and the extension is NDF. Then you have log files, .ldf, and log files, the purpose is to log all the operations you do in the database. Like for example, you would be inserting some data into the database. That information that you have inserted will be stored in the log file. So whatever operation you're doing on the database will be stored in the log file. And each of these files have both logical name and physical name. So you can see that in here, when I go to the property of a file will have a logical name, you can see in here, and will also have the physical name along with the path. So the logical name and the physical name could be different. So you can have a different logical and different physical names. This is how you have the structure of the database. Now, what about file groups? So we can have many file groups. The default file group is called primary file group. It stores information about the SQL Server system, especially the tables that are present inside the database. So it's called system table because it's storing information about your table. Then it is user defined. You can also have user defined file groups. And then the default file group is primary. Now, can I change the defaultness? Yes, you can change. So if you go to the database properties, if I go to file groups, so you have the option to change the default here. It's a checkbox. So if I click secondary as default, whenever I create a table, the data will go and set into secondary file group. If I create primary as a default, it will go and sit into the primary file. So the default here states whenever anything is created inside the database, where should the data go and sit? So it is the default database. So this is how it is. So you have the test example here. And test example, we have seen the primary or the default file. Now there are many files of different sizes. You can have those files in different disks. So how do I know I can have in different disks? You can go and again check the properties. And if you go to the files, you can see, you can specify here whenever you create, where should my data go and sit? So let us see when you're creating here. So you can see the option will be given for you to browse and specify where you want the data to sit. So I have two drives in my system, C drive and D drive, and I can choose like D drive, etc. to place the data. So this is where the data goes and sits. So this is how it is. Then you have something called proportionate fill strategy. What is this proportionate fill strategy? It means that whenever you have multiple files, going back to this diagram, whenever you have multiple files in a file group, when the data has to be filled, it will fill the data in the two files. How the data is going to be filled, that question will come. Is first all the first file will get filled and then the second file get filled, or how is it going to be filled? So the answer to this question is it is filled based on the sizes. For example, I have F3 and F4. Suppose F3 is 1 GB, F4 is 2 GB. Just for the sake of understanding, if you see this, then suppose I am entering 3 rows. One row will go and sit in the F3. 2 rows will go and sit in F4. Why? Because the difference between the sizes is 1:2. F3 is 1 GB, F4 is 2 GB. So the difference is 1:2. This proportional fill strategy is used here. So this is how the data is stored. So this is the data store strategy. Now, what about file groups? File groups can be marked as read-only. So you can have file groups which are read-only. It is the unit of backup. That means what? When you do a backup, you can specify I want to backup at the file group level. You can specify a table to be placed in the file group. We can specify which table can be placed in which file group, but you can never specify the file. Like for example, when you're creating the table, you have an option to specify the file group. So table is created under the database. So we say new table. So when you create a new table, you can specify the file group where you want the table to be. So all the data in that table will go and sit in the files inside that file group. So this is how you can specify. Then how do you design file groups? That question will come. So many file groups are there. How do we design? So for small DBs, you don't require multiple file groups. Primary file group is enough. DB means databases. For large databases, you require more file groups. So you can use a primary file group for storing only system tables. As I said, that's a good practice. Create files inside the file group in as many disks you want so that the data is spread. Otherwise, what will happen if you create only in one disk all the files? If the disk gets full, you cannot further enter the data. So therefore, we have to ensure that you have data in as many disks as possible or drives as possible. Okay, then you can use to place the file group to place specific object in the specific disk. You can also say sometimes file group 1 will contain all C drive files. File group 2 will contain all D drive. So one table will be in C drive, the data of one table, data of another table will be in D drive. So you can place tables used in join. We will see what is join when we come to query in different file groups. You can also place table and indexes in different file groups. Again, what is index? We will see in the coming classes. So this is the purpose of designing the file group. So with this, we will complete the topic today. Tomorrow, we will continue the class. But before I go on and we close this class, first thing I would like to do is just quickly share with you a link. Those who are new, who have not filled in this link, this is a student link. And if you are interested in this SQL Server class and want to continue, you can fill in this information. Madhav or somebody from Go Online Training will contact you and give you the details. And related to timings, related to cost, etc., all of it, you can speak to them. So before leaving the meeting, please do fill in this form. Okay. So with this, we complete today's meeting. Is there any question anybody would like to ask? Please do ask. So we have only 3 of us here right now, Divya, Manasi, and Yagnesh. So you can either refer to this particular demo that we just started, or you can refer to the demo which was previously given the first week of month of May. So you can check that also. I think 28th April, just before May, you can check all of that. So please do check all of this. And any questions that you have for me? So any changes or modifications suggested, if it is comfortable with all participants and does not involve extra time, we will accommodate that. So if you want me to change the methodology, we will change. So the basic methodology is theory and demo, and exercises will be given. So now I am just giving the theory and then the demo. I will then show how to create the whole database once, and will give you the exercise so that you all can do the exercise back and get comfortable. Okay, so this is the procedure that we will be following. Any questions from anybody? Divya or Mansi or Yagnesh? Yes, Mansi, you just fill in this form that I have given you and they will contact you. You can ask for more information, and based on the information they give you, you can ask if timing is convenient, etc. You can ask them. And then if you want to join, they will tell you, they'll send you the payment link and you join. Okay. So what about Divya or Yagnesh? We will. I will again give the student form. So you can fill in, please fill in this student form so that we can get back to you. We stop the recording.